Alright friend, let's jump right into our CompTIA A Core 2 practice. We are tackling Set 2 performance-based questions in the simulator today. You know that heart-dropping moment when a computer just refuses to start up? That is exactly what we are dealing with here, and fixing it is a core skill you absolutely need for the A+ exam, specifically the Core 2, and definitely for real-world tech work. So check out the scenario. A user's Windows 10 computer will not boot. It stops before the login screen, sometimes displaying a message like missing operating system or similar boot errors. We are already booted into the Windows recovery environment, often called WinRE, and we have got a command prompt open. This tells us Windows itself could not load its essential startup files. Now the instructions give us our mission. Use the right command line tools in this recovery environment to fix the boot sequence. Specifically, we need to tackle the master boot record, that is MBR, write a new boot sector, rebuild the boot configuration data, that is BCD, and finally check the system drive, C:. For errors using chkdsk, we need to type these commands exactly right. Think of the boot process like finding a specific room named Windows inside a huge building. The MBR, or master boot record, is like the building's main address sign outside. It tells the computer where the building is on the drive. The boot sector is like the instructions inside the main door, telling you how to find the building directory. And the BCD, the boot configuration data, is that detailed directory itself, listing exactly where the Windows room is and how to get in. If any of those are broken or missing, you cannot find the room. Let's look at the interface. We have our command prompt, ready at /sources prompt, just like in WinRE. See that initial error message about the BCD file being missing? That confirms our directory is messed up. Okay, let's fix this step by step, like a detective following the clues. First up, let's fix the main address sign, the MBR. The command is bootrec /fix MBR. That's bootrec /fix MBR. Let's hit enter. And the output is, the operation completed successfully. Okay, address sign repaired. Next, let's fix the instructions inside the door, the boot sector. The command is bootrec /fixboot. bootrec /fixboot. Enter, the operation completed successfully. Good. Sometimes this step needs the BCD fixed first, but it worked here. Instructions are now clear. Now for the main event. Rebuilding that corrupted building directory, the BCD. Remember the error message mentioned it specifically. We use bootrec /rebuild BCD, bootrec /rebuild BCD. Enter. It scans, finds C:\Windows, and finishes with the operation completed successfully. It found the Windows room and rebuilt the directory listing for us. Finally, what if the path inside the building, on drive C:, is full of potholes or broken tiles? That is where file system errors come in. Even if the directory is fixed, damage on the drive itself can stop things. So we run chkdsk. The command is chkdsk C:\f. That's chkdsk C:\f. The /f tells it to fix any errors it finds. Enter. chkdsk runs its scan and reports no problems in our simulation. If there were potholes, it would have tried to patch them. Path cleared. So we fixed the address sign, MBR, the door instructions, the boot sector, the building directory, the BCD, and checked the path inside using chkdsk. That is the logical flow. Just quickly, if we type HELP, it shows the commands the simulation knows. And EXIT would leave the recovery environment, displaying exiting recovery environment. And that wraps up this PBQ. We used bootrec with /fix MBR, /fixboot, /rebuild BCD, and chkdsk with /f to tackle a common and scary boot failure. Knowing these commands and why you use them is key. Okay, moving on to the second performance-based question in our CompTIA A Core 2 Set 2 simulator. This one directly addresses some great feedback we saw about the real exam, focusing on using command line tools to identify system and network information which is covered in objectives 1.2 and 1.6. Let's look at the scenario. A technician needs to verify network settings and system identity for 3 computers, client A, client B, server main, on a network using only the command prompt. Network documentation specifies the default gateway should be 192.168.1.1 and the primary DNS server should be 192.168.1.254. So our job is detective work again. We need to gather specific info: host name, IP address, subnet mask, gateway, and DNS server from 3 different machines using only command line tools, and then compare that info against the documented standards to see if anything is wrong. The instructions confirm this. Use the interface buttons to switch between simulated command prompts for client A, client B, and server main. On each machine, use the hostname command to verify its name. On each machine, use the ipconfig command to view its IP configuration. Compare the default gateway and DNS server output from ipconfig on each machine against the network documentation standards provided in the scenario. Identify which machine, if any, has an incorrect configuration. The help command lists supported commands. Alright, let's check out the interface. We've got the network standards conveniently displayed right here. Gateway 192.168.1.1 and DNS 192.168.1.254. Below that, we have buttons to select client A, client B, or server main. And below that is our command console, which will show the prompt for whichever machine is currently selected. We also have a reset all button. Let's start with client A. It's selected by default. The prompt shows c:\users\user A prompt. First, let's verify the hostname. Type hostname, enter. Output client-A matches the button, good. Now let's check the IP configuration. Type ipconfig, enter. Okay, we see IP address 192.168.1.50. Subnet mask looks right at 255.255.255.0 and default gateway is 192.168.1.1. That matches the standard. And DNS servers. It seems basic ipconfig didn't show the DNS on this machine, but the gateway looks good. Now let's switch to client B. Click the client B button. The prompt changes to c:\users\user B prompt. Let's run the same commands. Hostname, enter. Output, client-B. Okay, now ipconfig, enter. IP address 192.168.1.51. Subnet mask is correct. Default gateway is 192.168.1.1. That matches the standard. Ah, look! DNS servers show 8.8.8.8. The documented standard is 192.168.1.254. So, client B has the wrong DNS server configured. That's likely our culprit. Just to be thorough, let's check server main. Click the server main button. Prompt changes to c:\Windows\system32 prompt. Type hostname, enter. Output, server-main. Correct. Now ipconfig. Enter. We see its IP, correct subnet mask. Default gateway 192.168.1.1. That matches. And DNS servers show 192.168.1.254. That also matches the standard. So, by using hostname and ipconfig on each simulated machine via the command line and comparing the output to the documented network standards, we identified that client B has an incorrect DNS server setting. This PBQ tested your ability to use basic command line tools like hostname and ipconfig for information gathering, and just as importantly, your ability to interpret the output and compare it against known standards to spot configuration errors, a vital troubleshooting skill. Okay, let's get ready for the next challenge. Alright, moving on to PBQ number 3 for Core 2 Set 2. This one tackles a procedure you absolutely need to know inside and out for the exam and for real-world information technology work. The standard procedure for malware removal. This is directly from CompTIA A+ Objective 3.3. Let's look at the scenario. A user reports their computer is behaving erratically with frequent pop-ups, slow performance, and unexpected browser redirections, indicating a possible malware infection. You need to address the issue systematically. Classic malware symptoms: pop-ups and sluggishness are big red flags. Our job isn't to run the tools here, but to know the correct order of operations. The instructions confirm this. Review the list of common steps involved in the malware removal process. Arrange the steps into the correct chronological order as recommended by CompTIA best practices. Use drag and drop to reorder the list items. Now, the interface. On the left, we have our available steps pool. These are the correct actions, but currently unassigned. On the right, we have 7 numbered slots under correct order. We need to drag each step from the pool on the left and drop it into the correct numbered slot on the right. We can also drag steps between slots if we make a mistake, or use the red X button to send a step back to the pool. Let's think through the logical process. Step 1 is always to identify and research malware symptoms. You need to understand what you're dealing with before you jump in. Let's drag that to slot number 1. Step 2. Before you try to remove anything or connect to the network for updates, you need to stop the malware from spreading or calling home. So you quarantine the infected system. Disconnect it from the network. Drag that to slot 2. Step 3. In Windows, System Restore could potentially save infected files or restore the malware itself. We need to temporarily disable System Restore. Drag that to slot 3. Step 4. Now we actually fight back. This is the remediate step. This involves updating your anti-malware software definitions. You might need to use another machine and a USB drive if the infected one is quarantined, and then running scans to remove the malware. This might require booting into safe mode or even using a pre-installation environment if the infection is deep. Let's drag this big step to slot 4. Step 5. After cleaning, we need to make sure the system stays clean and prevent recurrence. So, we schedule future scans and run necessary operating system and software updates to patch vulnerabilities. Drag that to slot 5. Step 6. Now that the system is clean and updated, it's safe to re-enable protective measures. We enable system, restore and create a new clean restore point. This gives us a safe point to roll back to after the infection is gone. Drag that to slot 6. Step 7. Finally, the human element. Educate the end user on safe practices to help prevent future infections. This might involve warnings about suspicious links, downloads, or email attachments. Let's drag that to the last slot, number 7. And there we go. All steps are placed, and the interface confirms order is correct. That's the CompTIA 7-step malware removal best practice procedure. Remember the order: identify, quarantine, disable, restore, remediate, schedule /update, enable, restore, educate. Knowing this sequence is crucial. This PBQ really tested your understanding of that standard procedure, a key part of software troubleshooting and security in the Core 2 objective. Alright, let's tackle the 4th PBQ for Core 2, Set 2. This one gets into practical security configuration within Windows itself, specifically dealing with the Windows Defender Firewall. This lines up with CompTIA A Plus Objectives 2.5 on security settings and 1.3, which expects awareness of common MMC snap-ins like the Firewall Configuration tool. Here's the scenario. A custom development application requires incoming network connections to function correctly during testing on the local private network. You need to create a specific inbound rule in the Windows Defender Firewall to allow traffic for this application. Okay, so we have an app that needs to accept connections from other computers on the same local network, and the firewall is currently blocking it. We need to poke a very specific hole for it. The instructions give us the details. Simulate creating a new inbound rule. Select the rule type appropriate for specifying a network port. Specify the correct protocol, which is TCP, and the required specific local port, 8080. Choose the action that allows the connection. Apply this rule only to the private network profile. Give the rule a descriptive name like dev-app port 8080 and finish the configuration. Now the interface. This simulates the key steps you'd go through in the Windows Defender Firewall with advanced security when creating a new inbound rule. We need to make the correct selections in each section. First, rule type. We're allowing traffic based on a specific port number, not a specific program or predefined service. So we need to select port. Okay, selecting port correctly reveals the protocol and ports section. The instructions specify TCP port 8080, So under protocol, we make sure TCP is selected. Then under ports, we need to choose specific local ports. And in the text box that appears, we type 8080. Next, the action. We want to allow this traffic, so we select allow the connection. The allow if secure option usually involves IPsec, which isn't needed here, and we definitely do not want to block it. Now the profile, this is important for security. Network profiles domain, private, and public define how Windows treats different networks. Domain is for corporate networks joined to a domain. Private is for trusted home or work networks. Public is for untrusted networks like coffee shops. We only want this rule active on the local private network where the developer is testing. So we need to uncheck domain and uncheck public, leaving only private checked. Finally, name. We need a clear, descriptive name so we know what this rule is for later. The instructions suggest dev app port 8080. Let's type that in the name field. The description is optional, so we can leave that blank. And that's it, we've configured the rule. Type is port, protocol is TCP, port is specific 8080, action is allow the connection, profile is private only, name is dev app, port 8080. We have successfully created the specific firewall exception required by the scenario. This PBQ tested your ability to navigate the concepts within the Windows Firewall rule creation process, focusing on allowing specific ports and applying rules to the correct network profile, which are common tasks for desktop support and network administration roles. Let's head on to our final question for this set. This one dives deep into a fundamental Windows concept, managing share versus NTFS permissions. Understanding the difference and how to configure both is absolutely crucial for security and administration, directly hitting CompTIA A Plus objectives 2.5 and 1.6. Let's check the scenario. You are configuring access to the shared project docs folder on a server. The managers group needs to modify files, the sales group only needs to read them, and the everyone group should not have access via the share mechanism. Appropriate NTFS permissions must also be set. This is a common requirement, controlling who can even connect to the share, and then controlling what they can do once connected. The instructions lay out the steps. Access the folder properties simulation. Go to the sharing tab. Remove the everyone group from the share permissions. Ensure necessary groups have share access. Then, go to the security tab for NTFS permissions. Add the sales group and grant read-related permissions only. Add the managers group and grant modify permissions. Apply changes. The key here is the 2 layers of security. Think of it like a building again. Share permissions are like the security guard at the main entrance to the whole building, the network share. They decide who gets into the building at all. The most restrictive permission between share and NTFS always wins. So if someone only has read at the share level, even full control NTFS will not let them write over the network. Standard practice is often to keep share permissions simpler, maybe authenticated users change, and let NTFS handle the fine-grained control. NTFS permissions are like the locks on the individual office doors inside the building, the actual files and folders. They control what someone can do once they are already inside the building. These are much more detailed: read, write, modify, full control, and so on. Now, the interface. It simulates the properties window for our project docs folder starting on the sharing tab. First, we need to deal with the share permissions guard. The default often includes the everyone group with read access, which is too broad. We need to remove everyone. Select everyone in the list and use the remove button, which is the X button next to the entry in the simulation. Click the X next to everyone. Good. Now, who should have share access? We'll assume authenticated users with change permissions is the secure default we want here, ensuring everyone is gone. Now click the Security NTFS tab to configure the locks on the office doors. We see the default NTFS list: System, Administrators, Users. We need to add sales and managers. Let's use the select to add some, drop down, pick sales, and click add. Then do the same for managers. Select managers, click add. Now select sales in the top list box. In the permissions below, we need to grant only read-related access. We will check the allow boxes for read and execute, list folder contents, and read. Crucially, we make sure that Write and Modify remain unchecked. Next, select Managers in the top list box. They need Modify access. We check the Allow box for Modify. Notice how in Windows, checking Modify usually automatically checks the boxes for Read and Execute, list folder contents, Read and Write as well, because Modify includes those abilities. We've now configured both layers. Share permissions are reasonably secure by removing Everyone, and NTFS Permissions grant specific access. Read for sales, Modify for managers. Clicking Apply or OK in a real window would save these changes. Remember the key takeaway: the most restrictive permission applies when accessing over the network. This PBQ tested your knowledge of configuring both share and NTFS permissions, understanding their distinct roles, and applying permissions to specific user groups, all critical for the A+ Core 2 exam. And that's a wrap on our 5 Core 2 PBQ simulations. We worked through boot commands, network diagnostics, malware procedures, firewall settings, and file permissions, all essential skills for your A+ journey. Practicing like this helps solidify the concepts, but if you're looking for a more structured path to get certified efficiently and confidently, that's what TechVaultAcademy.com is all about. Think of these YouTube videos as a helpful starting point. Over on the website, you'll find a deeper dive with comprehensive study plans, loads of practice exams designed to mirror the real test, detailed breakdown guides, and the systems that have helped thousands of students prepare effectively, many going from 0 to certified in about 6 weeks. So, if you found value here today and want to explore those extra resources to really boost your exam prep, feel free to head over to TechVaultAcademy.com. You can check out the different study materials, see if a plan fits your schedule, and grab some helpful guides while you're there. The link is right down below in the description if you'd like to take a look. Thanks for practicing with me today. Keep up the great work, and I'll see you in the next video.